Hello and welcome to this video about sockets and multi-threading. In this video we're going to take a look at how to handle multiple clients at the same time. If you saw the previous video, you saw that there were some problems and we could only handle one client at a time. So this time we're going to fix that. Right, we'll just refresh what the problem was and then we will take a look at how to fix it, the idea. We're going to take a look at a very simple chat system. That means that we want the clients to be able to interact with each other one way or the other. And then we want to make the client listen for input from the server. So again, the idea and how to do it. So in the previous example, with the echo server, the client would send a message to the server and the server would send one back. So every interaction between the two were initiated by the client. But if we have a chat system, then we might see the case that a client is receiving something from the server, the chat message, without having requested it. So we must make it so that the client is ready for these push notifications from the server. That's the idea. All right. In the previous video, we only sent strings. I just sent a string through the sockets, the object streams. But we can send many different things. We can send symbol types, we can send strings that we saw, and we can send actual objects. So anything that is serializable, meaning that it must implement the serializable interface, we can send that type of object. Some of you used serializable on the first semester to write a list to a file. Lists are by default serializable, so we can send those, and we can create our own data transfer objects or transfer object. So we'll see this. This is the usual approach. You should rarely send strings and symbol types. We usually want to send objects. That gives us a little more control. So just to refresh the problem, this was the server. Last time, my simple echo server, we created the server socket, we accepted a client connection, we created the streams, the communication devices, we read an object from the client, in my case a string, we changed the string to be uppercase and we sent the result back to the client again. So as you can see in my comments, we were stuck here until a client connects. The server is waiting here, and we were also stuck here until we could read an object from a client. So I could not read objects from two clients at the same time. I could not handle two clients at the same time, or even more than that, and that's what we're going to fix today. So today's goal is that I have a server, that's a socket, and that's a client, and we want to be able to handle multiple clients. So the two are connected, and in the previous example we saw that I send a message and I send a message back again to uppercase, and now the end result of today's session is that I can send a message, and that message should be sent back to all clients, so a kind of chat system. All right. So we saw that we were only able to handle one client at a time, so that's where we are. We're going to start to fix that problem, right? So we can handle multiple clients over here. I'm going to need to handle something over here as well, as I mentioned, so that the clients can read sort of unexpected messages. So first, the idea on how to fix the problem. Whenever we have a new client that connects, we're going to make a new thread. And that means for all interaction with this specific client is happening through that thread. So here's the idea. The client connects to the server. The server creates a new socket instance, which we hand over to a thread. And these two can then communicate with each other while the server goes back and is ready for the next client to connect. So my server is waiting for the next client, and we are handling a client in this specific thread over here. So they are not interfering with each other. If this thread is waiting for input from the client, it's just waiting over here. We're not blocking anything over here. So that's the idea, splitting the behavior, the responsibilities out into multiple threads. So let's give that a shot. I will open my IntelliJ from last time, and we're going to modify the program. So let me just create a new one. I will create it. Here's a multi-threaded echo example, and yeah, I'll just steal everything. No shame at all. Yes, and it's also adding to Git, so that's wonderful. And let's just make sure I didn't mess anything up. That didn't go into packages, for example, so that's, we'll say client, and I just take these two, drag into there. I just like to have things separated, so I know where to find my classes and my responsibilities and so on. And I will create a server package, so everything that belongs to the server goes in here. It's easier when you keep it separated. Okay, so the first thing we want to do is to make sure that currently, let me just start it. The server keeps running whenever we connect with a client, and then handle that client's once it's terminated afterwards. But we want to keep the client running as well. Okay, we're starting the server, so let's just remember what happened here. Echo client started. I could type something in, hello, and we get something back, and the client terminates. The server is still running, so that's nice. So let us instead say that the client here, I want to repeat the behavior. So this part here, that's the thing that I want to do over and over, so I can keep typing a message. I can highlight it and select, press Ctrl-Alt-T. That gives me a surround with, and I want to surround with the while. So I'll just do like this. So it's just a true for now, that's fine. I only ever want to create, for each socket, I want to create only one instance of each of these. So they go outside of the while loop. And it's annoying to see that it's complaining about finding the duplicate code, so I should be able to, that didn't happen. Anyway, I should now be able to run my server. And of course this, no, why do you keep asking? I forgot something. So my client is keeps sending stuff. My server, it only reads and writes to the client once. So we will also here say surround with a while true, like this. And then maybe I need some way to break out of this. So my server here, we're creating a server socket. We are accepting client connections. For that client connection, we are creating the streams, and then until the end of time, while true, we are reading and sending stuff back again. So let's say I read something. If read equals exit, I'll just equal ignore case. Then we want to break out like this. And break, we skip out of the while loop, and then we start over here. Can I actually close? Like that. So I want to close the socket. On the client side, I want to say, I write something to the server. If s equals ignore case exit, then I also want to say socket.close, and we want to break out. So this is the way to shut down my client now. And because I'm shutting it down, I don't expect to read something back, so I'm just breaking out here. That means we're breaking out of the loop. We skip out, and there's no more code to execute. So let's see what I have done now. Starting the server. Please type, we type hello. And my server is still running. My client is still running. Good day. And I get that back again, hello again. And if I type exit, terminates, and the server is ready for the next one. So I can create a new client. I can run that again. New client. Okay, so let's try and start another client. So now I should have two clients running, trying to interact with the server, and I cannot run it in parallel, so I have to go up here, edit configurations. I have another echo client, number 1. That happens when you copy things. Bit confusing. We allow parallel run. I try again. Start echo server. That's not the one I want. Echo client. Start echo client. There we go. So I have my server running. I have my client here. This one can still do stuff. But this one, there's nothing here. It's not waiting for input. So if I type exit, then this one is ready. Hello, from the new client. And I can get that back. So my I have made it so that my, let me just stop everything. You can see stop all up here. I've made it so my server here is handling one client, multiple times, so to say, until the client is finished. We'll read and exit. And I have done it so that my client is also reading messages from the input over and over and sending back and forth between the server until we type exit. But I could still only handle one client at a time. So the first client, we're stuck in the while true. When we're done here, we go out and we handle the next client, and then we're stuck in the while true for that one. So according to this one here, whenever we connect, we want to create a new socket, socket thread, we could call it, a new thread that handles the socket instance and then handles the behavior for that interaction between the server and the client. So we're going to create this thread here, and I'm going to say new, I call it client handler, server handler, server, socket, handler, doesn't matter. We need to make it into a thread, so I can just do it like this, implement runnable, and I have to implement the run method like this. So I'll just split here so we can see, and the echo server here. So the behavior that means handling one client, I need that to be in the thread now. So that means creating the streams and doing the reading and writing back and forth. So I take that and I put it over here. We have to import things. All right, and this one we have to surround it with a try catch. I do it like this, try catch. There we go. Sometimes I see that the try catch is inside the while true. That's going to potentially spit out a bunch of errors. We want it outside the while true. So if we fail, we just break out and terminate. We don't want to keep failing while true. All right. So that means the behavior is now in the runnable class here. I need to create a new one over here. So whenever we connect with the socket, I create a new thread. New thread. I need an equal sign, and I give it my socket. No, not like that. Sorry. I need to create a new server socket handler. Like this. And this one needs to know about the socket, so I will give it the socket It's complaining because it doesn't recognize a constructor that takes that argument. So I can just Alt Enter, create a constructor, and we will see that I got the constructor over here. I have my thread. I give it my server socket handler, and then we say t.start. And then I don't need to catch this one anymore. E, like that. Okay, so this is my new server. We start the server socket here, create it. We accept the client. We create a new thread to handle that client, and we start the thread. And then we are ready to go back and accept the next client. And again, create a thread and start that next client, and so on. So this is what I need to do for my server to make it multi-threaded. Whenever a client connects, we just create a new thread and handle that connection in that thread. So this is a sort of template solution. You can reuse that. Let's take out the rest of this one. So I need to know about the socket. So I will say this socket equals socket, and it will then recognize that it needs a field. By default, it creates it final. That's fine by me. It means it can never, this cannot be assigned outside of the constructor. So that's okay. Sometimes it makes sense to have these created in the constructor and has as field variables. In my case, I only need it in the run method, so I will just create them down here. All right. So that's on the server side. Now it's multi-threaded. Whatever is needed for handling a client, it happens in a different thread in here. And if I run everything again, we should see that both the clients here can be interacting with the server at the same time. So let me just give it a go. My server is started. I will start my first client. It's ready to type in a message, and my server says client connected. So now the big test. Let me see if I can create another one, and it's actually also ready. So they're both ready, and the server has two connected clients, and I can interact with one of them, hello, and the other one, other hello, and I can still hello again from the first one. Wonderful, and back and forth, and the server is printing out stuff. I can terminate the first client here by saying exit. That will terminate. My server is still going strong. I can still strong, and we can terminate the other one by typing exit like this. So we are now able to handle multiple clients, and it is absolutely wonderful. I have my Echo server. This is the only thing it does. Now the responsible is just accept a client connection, hand that client connection over to a new thread. Good. And let me just push this to GitHub. You'll see that there's a version control tab down here. There's an unversioned file. I don't care about those. I have the default change list. Whenever I add something new here, new class, GitHub will ask, do I want to add it to GitHub? And if it's a class, I probably want to add it. But for my example, I don't want to, because I just want to delete it again. So that's how GitHub. So you're getting a super brief GitHub introduction also. So it keeps track of the classes that are under version control. GitHub knows about them, and these are the ones that I've changed or added. I will say commit them, some message. Let's just make it multi-threaded server. That's fine. And I can either commit, which will put it in my local storage, and then I push afterwards, so I can push it to the cloud storage. So I'll just do both here. I have some warnings, no one cares. There we go, it's pushed to GitHub, and you can now, yes, I just final push here, push and shove and so on, and you can find it on GitHub with my, let's just see, socket videos, echo example. There we go, multi-threaded echo example and so on. Wonderful. Okay, so let's get back to the presentation. All right, so The next step is the interaction between the clients, but first let's just recap what we did. I had so it's a bit small, but this is the server socket handler. I call it in my code. My slideshow is called server connection, but the idea is the same. It gets the socket and we are reading and writing to and from the client. And each client is interacting with this thread that may or may not know about the server in your assignments and the semester projects, and it's going to know about the server probably. But each client is connected to a separate thread, so that's why we can have multiple clients running at the same time. Right, so what we saw was that this is the lifetime of the server running. The first client is connecting. It creates a new thread that is now running in parallel to the main method or the main thread on the server. So now the client is interacting with this thread and can through this thread interact with the server if needed, like this. The other client connects, also creates a new thread, and again we can interact with the thread, and through the thread, if we need to, we can interact with the server and back again. So we're going to need to interact with the server in the next part where we do the chat kind of thing. Okay, so now in my example here I have the main thread and I have a one client thread and another client thread running. Alright, so each client is handled in a separate thread. We no longer see the blocks that the one client blocks for the others, and we still just have an echo uppercase example, so it's still somewhat boring, but we are expanding step by step. Alright, so the next step is the interaction between clients. When I send a message to the server, that message should be received on all clients. So that's our chat system. And the question is, how do we achieve that? So the idea is that whenever the server thread receives a message from a user, that message is broadcast to all the other clients. That's what we want to achieve. Right. We send a message to the server sends that message back to all connected clients. We do that by creating a class that holds all the existing connections. Just a list of the socket handlers we saw, and we must now make the clients listen for messages from the server. Right, so it looks something like this. The client connects to the server. I create a new thread, a new socket handler. That socket handler goes into a class called the connection pool. It's just a list of socket handlers. Server connections, server socket handlers, whatever you want to call that class. It could look something like this. In the server class, we accept the connection. I create a new server connection, that's the thread, and it knows about the connection pool. And we also add this server connection or server socket handler to the connection pool, and then we start a new thread. So client B, the next one, connects. That has created a new thread, and that thread is also going into the connection pool. Client C connects, we create a new thread. I now have 3 parallel threads running. The connection pool knows about these 3 threads. So I will just collapse them into, these are all the threads running on the server, my server and my connection pool here. So the idea is that whenever client A sends a message, we send that message back to everyone. Maybe we don't send it back to client A, that's an optional feature. We could just print it out straight away, but we're going to do this anyway. So this is the next step. That's what we want to achieve. I send a message and it goes back to all the clients. All right. So the approach is that we need a server socket handler thread on the server side so we can handle multiple clients. We're also going to need a client socket handler on the client side so we can listen for this input from the server. Because otherwise the client is blocked until we get a response back from the server. But we want to be able to send and receive independently, so in 2 different threads. there's also sometimes the benefit of doing this in multi-threading on the client side, that the calls to the server can take a long time, and it can make the system seem more responsive if we are not waiting for a response back before we can react again. So this is a common approach that we will see in future semesters also. So the point of having this client-side socket thread is that we can just fire away a request to the server, and then the user can keep working with the program. At some point we get a response back from the server, and then we can update the client accordingly. So this is what we call asynchronous. Alright, so to do the chat program that we talked about, let's take a look at UML diagram. I have a client and a server class here to run them. My socket client is going to connect to the socket server, and that will spawn a new server socket thread, server socket handler, and that server socket handler is going into my pool here. So that means the pool must have a list of all the server socket handlers. There must be a method to broadcast, and there must be a method to add a new server socket handler connection to the connection pool here. We will be sending messages instead of just strings, just to show that we can do it. And then we need the client socket handler on the server side to be able to receive messages. So let's give it a go. That's not IntelliJ, that was Rider. That's next semester. Okay, so we will say new, not a class, I want a package. We will say chat example sockets. Yeah, that's sort of implied. Chat example, I need a client package, and I need a server package, and I want to move that to here. Okay, so let's start by creating a chat server. I want to add it, yes. I will also create a start chat server like this, and we're just going to say in here, similar to what you saw in the previous parts, chat server, a new one of these, and I need a start method. I can call it whatever. I like to call it start. So let me just create this. So in the chat server, I must create a socket, a new server socket like this. I have to import it, and we give it a port number. I just go with 2910, that usually works like this, and I need an instance of it, so we call it server socket. That's fine. I want to surround with a try catch. Here we go. Then we have the while true, so I just want my server to keep accepting clients. We say server socket accept. That gives me a I'll call it socket like this, and here we need to create server socket handler and start thread. I'll just do like this. If you put to do, it's highlighted, and there is actually a to-do list down here, so you can see, oh, I have to do cases in here, 2 things I need to do. Okay. Yes. So I will create the server socket handler. Maybe we call it something chat socket, chat server handler, like this. Yeah, I want to add it. We implement the runnable. And I need to know about a socket here, private socket, socket, like this, and I need a constructor, alt insert, and I can just say I want to have a socket like this. Why is it underlined? I don't know. I also need a private object input stream, in. I need a private object output stream, out, and I will create them down here. In equals new from the socket.get input stream. We say out equals new from the socket.get output stream, like this, and it complains that we must surround with a try catch, like this. There we go. Okay, so let us just make sure that we have whatever is needed. So we just have a we start with the echo part, exception E. So it's going to initially be a boring chat client. You can just chat with yourself. So we have a while true, and we have here, I want to say in read object, and what are we reading? Well, I need a message this time, so let me just create that. We create a shared folder, so everything that is used on both the client and the server, I put that in a shared folder like this. We have a message, and I can, so this one, because I send it across the network, I need to implement serializable like that. And we have a private string message body, and I want a constructor, alt insert with that. And I probably need a getter for this one, so I can get the message body. I could have maybe a username if I wanted to. Maybe we will do that later on. Okay, so it's messages I want to send around. So let's go back to my server handler here. I know that I'll be reading a message like this and like that. We could print out the message dot get message body, and then we will just out write object. I'll just send it back again for now. So it doesn't do much. We're just sending it back and forth, just to make sure that we can have the multi-threaded server working, handling multiple clients, but they are not initially contacting or communicating with each other. Chat server. Let's just print out server started. Okay, so I need to create the server socket handler, or the chat server handler, like this. New, and it takes a socket like that. I create a new thread. I give it the chat server handler, the runnable class here, and then we start the thread. Okay, so that's those two to-dos. I do need another to-do. Create connection pool. I need here update to-do add to connection pool, like that. We will get back to this, but now I don't forget it. So my server should now be able to accept a client. We handle that client in a separate thread, and that happens over here, and we are reading a message and sending it back again. Okay, this one is gray, never used. Public chat server handler. Something iffy is going on. It should be used. I don't know. We'll continue with the client and see if something is broken. I will create a chat client. Yep. I have a void public void start client. like this. So let me just create the main method here. I like to have those in separate classes. Start chat client. So the only thing my main methods do in general are just starting things. Chat client, like this. So it's just an easy startup. Then we're done with the main method. Okay, so the chat client we'll do similar to last time. We need a socket. Yeah, I need to import it, and that's a new socket. We give it localhost. The port number is 2910 in my case. I have to surround it with a try catch, like that. And I want to send something. So let me start by, we do that over and over, while true. If, let's say, I need to create my object streams out here. Object output stream, out, like this. And we give it the socket dot get output stream, like that. And object input stream, in, socket get input stream, like that. So those are my streams. I need a scanner to read from the keyboard. New scanner from system.in, like that. And Control-Alt-V to complete that. So I want to read something from the keyboard. Scanner.read next line. This will give me a string. I call it message. Then I need to wrap that inside a message. So we create a message. And you can see I have to import it from the shared folder. If you ever start on your client side to import something that's in the server folder, then you're doing something wrong. New message, it takes my chat message, like that. We send it to the server, out, dot write object m. Then we want to read something back from the server, and we are reading a message like this. I'll call it response. I have to add a catch clause because I could potentially read an object that doesn't exist on the client side. I'll just collapse these two, alt enter, here we go. And let's just print out the response, get message body, like that. Okay, I also still want to be able to terminate the client, so we say if message equals ignore case exit socket.close, and we want to break like this. And on the server side I want to do the same thing. So let's just get this one. I create a new body like this, and we print it out, and we say if body equals ignore case exit, we close the socket like this, and we break out of the while loop, and then it's just terminated down here. Okay, so that was basically what we did in the previous session, a bit fast, but same idea, we're just sending messages instead. Now the test to see if this actually works. Let me close this. We want to start the chat server. There we go. And we're just waiting for it to compile. Need a faster laptop. Alright, server started. I just close those. We say start chat client, and I want to start that. And maybe I just want to, so there's nothing printed out because that would be nice, right? So let me just print out input like this, and we start everything again, just so it's indicated that I'm actually expecting to insert something in my console. and this one fails because the client was terminated unexpectedly. So that's to be expected. It was trying to read from the client that was terminated, so that gives a connection error. Okay, chat client. Hello. I'm getting something back in. Wonderful. Let us start another chat client, and I have to remember to go and say I want to run in parallel up here. Chat client. Okay. That should now be possible. And this one is still working. I get that. This one also working. I'm getting that, and my server is wonderful, and everything is good, and it's amazing, everything, and that is nice. Okay, so I've recreated my echo kind of thing. I can just talk to myself now. The next step would of course be to be able to talk to the others, so I need the extra connection pool here, and I need the client socket handler here. We will start with this one, I think, yes. So my chat client, currently it is always expecting me to send a message and then read a message right away. But sometimes, you know, I would need to read 2 messages from other people in a row because they are eager in sending many messages. So I want to take that part, the reading of messages, and do that in a new thread. So let's take that part and move out into a separate thread. Whenever we start up here, I'm going to do this sort of quick and dirty. Let's just do it like this. You will see something new. I start a new thread, and I just call start right away, don't I? Let's do that for now. And I want to take this part here, reading the object and printing out. I press Ctrl Alt M. That will ask me to extract that as a new method. And we're just calling it listen to server. Like that. And I don't want it here. And okay, that didn't go exactly as planned. What did I mess up? Like that. Okay, so I want to be running this method here, and I don't want that. And I don't want that. Okay, my refactoring didn't go all that great. Instead, I need to create this as a field variable. Okay, so it's up here. And here I want to say, set1, listen to server. So we'll get back to that. Hang on, let me just try catch this one. Okay, a lot of things happened, so let's just check. I still create my socket connection to the server. I'm creating my streams, object and output. I'm keeping this as a field variable because I need to use it outside of this method. Right, so this variable is used in multiple methods, so I have it as a field variable. I have my scanner to read from the keyboard, and I will just move that up because we need that afterwards. And here I'm creating a new thread, and I'm starting it right away, and I'm giving it a lambda expression, and I have some material about lambda expressions. So it's basically just saying that run this method in a different thread. That's what we're doing. So it's a very shorthand version. Instead of having an entire class that implements runnable and then a run method, I could do the same thing, but here I'm basically just saying very implicitly that I have a separate class that implements runnable, and in the run method I'm calling this method here. That's sort of what's going on. So shorthand notation, I'm just running this method in a separate thread. And of course we want to keep listening to the server, right, while true. There we go. So I'm constantly trying to read something from the server, and whenever we read it, we print out the response. That should be it. maybe I want to make that as a daemon thread. Let's do that instead. Say thread.set daemon true, and then we start the thread. Thread.start. So whenever I have a daemon thread, it means that if this is the last thread running, then it will terminate itself. And if I press exit here, then I want this thread to terminate also, or type exit. That's the idea. So I have now the client socket handler also. Here's an external class. I made it sort of internal, implicit. So I don't have an actual class. You could do that just like the server socket handler or the chat server handler. What did I call it? Chat server handler. I could do that similarly, but it's doing so little that I'll just do it as a thread here. So this is the lambda expression. You can also use a method, what is it called? Method reference. You will see that it is highlighted in yellow. So I can all enter and replace. So it's just, again, same thing. We're just saying this method should be run in a separate thread. All right, it's time to see if I broke anything. That's always interesting. I will start the chat server. And just drag this up a little bit. I will start a chat client. There's an input. Let me just start 2. Hello. It's still printing out. Still working. Working like a boss. Okay, let's see what happens if I press exit. And I do actually get a socket closed. That's probably because we terminated the thread. We'll leave it like this for now. Maybe we will get back to it. So my chat clients could communicate with themselves, but not with each other. So for that, we needed that connection pool. So let's create a connection pool. This will contain a private list of chat server handlers. Let's call it connections. I need a, let's instantiate it right away. Array list, that's probably fine. I need a method, public void. Alright, let's see, what did I suggest? I need a method to add a new connection and a method to broadcast. So public void add connection. It takes a chat server handler. Chat server handler. We say cons add like this. And I need a broadcast. Broadcast takes a message. And I will go through my chat server handlers. So for each of these, I want to say send message to client, and it takes the message. So I want to send this message to the client, all of them. And I will just create that message method like this. So that is in the chat server handler. If we take a look at the UML diagram, there's a send message. I call this slightly different. Send message to client. And in here, I will say out. Well, I'm basically doing this like that. Message. And I have to surround with a try catch like that. All right. So whenever we receive something from the client, it's printed out, and if everything is well, then I want to make the broadcast here. So in order to do this, I must know about the connection pool in this class. So let's say it needs a private connection pool, and I want that through the constructor connection pool, and we say this pool is equal to the pool. There we go. So I'm getting that through the constructor. I'm assigning it up here so I can use it across the class. And we say whenever I get a message, I'll just say pool.broadcast, and the message is message. So that should now be sent out to all the clients. For each of the active chat server handlers, we are calling this method, which will write back to the client. So I need to modify the chat server a little bit, because this one now expects a connection pool. So create connection pool, I have it there, but let's just do that. Connection pool, new connection pool. And I want to make sure that I'm using the same one all the time. There should only be one. Sometimes I see that people create a new connection pool in the chat server handler in here, but then you have an instance per thread, and that only one knows about one chat server handler. So create it here. Whenever I create a new one of these, I will say I handed the connection pool. We also need to add the connection like that. So that to do is done. All right. Let's see what happens. So now we accept a client connection. We create a new handler. We put that handler in the connection pool and then start a new thread, and we start over to accept the next client. The connection pool has a list of all the connected clients, and we can loop through that and send a message to each of them. So let's expand a little bit before we start. This one here should also have a private string user, and I want to give it a string user. This user is equal to a user, and I need a get method for that. Get method, and maybe I have a toString method also. So let's override that to string like this, and we are returning user plus message body like this. Okay. Let us just change that in the chat server handler. So instead of printing out the message body, here we just print out the message like that. Okay. Now let's see what happens. I want to start the server. I need to do something in the chat client because I haven't set the user. So chat client, initially we will say insert username, and we are going to say scanner read line, next line. That is going to be my username like this. So I will keep that, and whenever I send a new message, I have the username like that. Okay. Whenever I read something here, I will do it like this. So now we print out the user and the message. Okay, this is interesting. I've done a bunch of changes and I haven't tested anything, so this is a fairly bold move. Let's see what happens. Not much. Let's just compile everything. Okay, I start the first chat client. It's ready for my username. Start the other one. We'll say trolls1, trolls2, and hello. And I'm actually getting back from trolls2 hello. And this one is also getting a hello message from trolls2. Amazing. And we say hello back. good sir. And I can see my own message. So I could of course filter by username and say maybe I don't want to send this back because I have that here, so it's kind of silly that I can see that I'm sending it to myself. So we do still get it here. So let's just fix that. Let's see how we can fix that. And I terminated everything and everything broke, so that's wonderful. Okay, so I want to say in the connection pool, I'm sending a message here. I must have a ifcon get user name, get client name equals con message dot user. So I'm going to set a username for each of the clients. So this one, I'll create a method. It returns a string, returns null. I'll have a username. So let's create this at the top here in my client handler, chat server handler, private string username. Okay, so let's change our protocol a little bit so that this is going to be absolutely wonderful. I'll draw in Paint. I have my client and my server, and they have the lifetime. And I'll just put here client and here server. And well, this is actually a handler, right? Okay, so first, can I draw an arrow? Maybe I shouldn't have. I'll try this one. First, we want to send the username and then we want to be able to send messages, and asynchronously the server might also send messages back again. So I could perhaps show that by saying, I'll just remove a little bit here, saying that it's happening in asynchronously. And so first I send the username, and the server should then not going very well. The server should set that username like that. So that's my new protocol. Okay, that looked amazing. Let's go here. First thing is that I'm expecting to read a string. And that will be the username. Oh, didn't work out. Username, like this. That's the first thing. And once we have the username, we're going into the while true here. Okay, that means on the client side, the first thing I have to do here is say out write object username, like that. Okay, so now I'm getting a username. I'm writing that username as the first thing to the chat server handler. It's setting that. Oh, okay, setting that. So that means each chat server handler knows about a username. Each chat server handler is handling the client specific for this user with this username. And that means we can loop through here in the connection pool. We can check, are we trying to broadcast a message to a client with this username? Then we want to skip that one like this. So if the username of this one is not equal to the username of the message, then we're sending it to that one. So the results would be that we are skipping sending messages back to ourselves. Let's see what happens. Doing this on the fly, so that's a bold move. Maybe everything is broken. We don't know. I start one client, I start another client, and I think this time I will start a third client just to spice things up. Here we go. Third client. Great. We say tools 1, tools 2, tools 3. Okay, and hello all, and I'm not getting anything back, so that's nice. And Troll said hello all, hello to you, and I'm getting from Trolls 2 hello to you, and this one here is hello to you all, and it's just me chatting with myself. Hello myself. Okay, that is nice. So let's try this one here. I do get that one. That's because the thread closed. We'll fix that later. But here, if I try to say something again, hello again, I'm getting a bunch of errors on the server side because I have terminated one of my clients here. One of these we received exit, so we terminate, the socket is closed, but whenever I try to send something from one of the other clients, we still try to send to this client as well. So I need to remove that. We say cool, remove, what was it called? Add connection, remove connection, this. Let's see if this works. CSH. Come on. And we say cons remove CHS. Okay, so that means I have removed a client handler from the list here. I was trying to send to all client handlers that has ever connected, and even though one of them disconnected, we're still trying to send a message using the object output stream, but the connection is broken, so I get a mistake here. You can see the blue stuff, line 52, it happens here. 52, I added another line, right? Now it's 52. So that's the error. Let's just see if this happens again. All right, chat server, I'll just do it here. Server started, start one, we start another, we start a third, and we say T1, T2, T3, and hello all, and we are seeing that the other places here, and I want to exit here, I want to terminate. Yeah, we'll fix that. And are you still there? Okay, we receive it here. I don't get any errors on the server anymore because it's not trying to send to the client that was terminated. So that is fantastic. Okay. Let us take a look at the, so I still got this one here that annoyed me a bit. So let's see if we can figure out what to do about that. So it happens because whenever I terminate, this method, we're also terminating this thread here. So we're not reading anything. So what should we do about that? All right, so I have a plan, and the idea is that we send an exit request to the server, and the server will then acknowledge that and send a exit response back again that we react to. So we start by saying we don't want a daemon thread, we want to terminate that manually. I need my socket to be a field variable created up here. Then instead of closing it here, we just want to break out the loop. So I'll just copy this and remove that. And if I read an exit here, response dot get message body, Then I want to close and I want to break, and then this one will terminate. So I need to send an exit to the server and get an exit back again. And let's handle that on the server side. Chat server handler. So whenever we receive an exit, I don't want to close it yet. I will break out. We will remove from the pool. We want to say out write object message. We want to just return that, and then we can probably go socket.close. And then we break. Okay, so we're doing a bit of a cleanup here. We're removing this handler from this connection pool. We are sending the exit message back again, and we're closing the socket. So let's see, and in the client we are reading exit. We are sending that to the server. We are reading it, so we break. We are reading back from the server. If it's exit, we close it and we break, and maybe it works. Let's see. Start my server. And a couple of clients. Another client. And another client. And 3 must be enough. We'll say T3, T2, T1. And we're saying hello all, just to see that it works. Everyone is getting that. Okay, we'll say exit. No errors here. No errors on the server. No errors in these, not yet. Hello, still there. And we get this one. This one is terminated. The server is not complaining. We don't get any errors, and I think that is good. I think that is very good. Okay, so that's the chat program. Let me just commit that. The minor changes here. And now terminating without errors. Yeah. So it's showing me I can actually check here what are the differences if I want to see. Okay, I added a line here, and I will just commit and push because I'm bold and confident. So there we go. Push. Come on. And then I think we should get back to the presentation. I have a few slides left, I believe. So there was a lot of programming. We made our chat client server system. Sort of looks like this, slightly different names. This one turned out to be an internal class, but we saw that well, something that you're going to need whenever you do client server with sockets. Later on you're going to see another technology called remote method invocation, but for sockets you need to have a socket handler on the server side. You will need a socket handler on the client side. And if you need some kind of chat thing, you could use type of pool. We will introduce another concept later on where there is a model down here, and the model is a subject, so it can send out notifications, and whenever a server socket handler receives a notification, it will send that to the client, which will then update an MVVM structure and so on. That's next session on how we combine sockets with MVVM. We saw that I can send the message object here. I gave it a user and a message body. So that concludes the introduction to sockets and multi-threading, so that we can serve multiple threads, so multiple clients at the same time. All right, that is all for this session. Thank you for watching.